Alright, to start this lesson, we'll take a look at the properties of equality. Alright, we're going to start off by saying that A, B, and C be any real numbers. And the first property is the addition property, and that is if you have A equal to B, then if you take A plus C, it's going to equal to B plus C. Right? So the left hand side is equal to the right hand side. The next one we're going to look at is the subtraction property, which is similar to the one we just looked at. And if you have A equal to B again, then if you take A minus C, then that's going to equal to B minus C. Okay? Next we have the multiplication property. And if you have A equal to B, then if you take A times C, that's going to equal to B times C as well. Alright, the next one is the division property. And if you have A equal to B and C is not equal to 0, then if you take A divided by C, that's going to equal to B divided by C. Alright, so for the reflexive property, you just have A is equal to A. Right? Pretty simple. As for the symmetric property, if you have A equal to B, then B is equal to A. Okay? Alright, the next one is the transitive property. And if you have A is equal to B and B is equal to C, then we can conclude that A is equal to C. Right? Since both A and C are equal to B. Okay, so we're down to the last property of equality, which is the substitution property. So if you have A is equal to B, then you can use B to replace A. So that means if you see A in an expression, you can substitute that or replace that with B, or the other way around. Okay? Alright, let's take a look at this example where we use the properties of equality as justifications to solve for x. Alright, we know that angle AOC and angle BOC are supplementary. So therefore, we can write down the measurement of angle AOC plus the measurement of angle BOC is equal to 180 degrees. And that's because of the definition of supplementary angles. Okay? Notice for the next line, I replaced the measurement of angle AOC with x plus 70, and I replaced the measurement of angle BOC with x. So the justification for that is substitution property. Okay? And to get to the next line, I use the distributive property. And to go from 2x plus 70 is equal to 180 to 2x is equal to 110, I subtracted 70 to both sides. So that's the subtraction property of equality. And the last one there, to get from 2x to x, I divided both sides by 2, so that's the division property of equality. Okay? Alright, we're ready to jump over to the properties of congruence. And the first one we're going to look at is the reflexive property. And if you have segment AB it's going to be congruent to itself, which is segment AB. And angle A is going to be congruent again to itself, which is angle A. So that is the reflexive property of congruence. Alright, the next property is the symmetric property. So we have, if segment AB is congruent to segment CD, then if you were to switch it around, segment CD is congruent to segment AB. And that works the same way for angles. So if angle A is congruent to angle B, then angle B is congruent to angle A. Alright, here's the first part of the transitive property. If segment AB is congruent to CD and segment CD is congruent to segment EF, then we could say that segment AB, which is this one here, is congruent to segment EF, which is this one here. Notice the similarity for the transitive property of congruence with the transitive property of equality that we did earlier. Alright, so here's the second part to the transitive property of congruence. If angle A is congruent to angle B and angle B is congruent to angle C, then we can conclude that angle A, which is this one here, is congruent to angle C. Okay, and we're finally done and we're happy.